In this video, we'll cover equations with variables on both sides. So we'll answer the questions, what are the parts of an equation and how do I solve an equation with variables on both sides of the equal sign? To answer the first question, some of the important parts of an equation are listed here. So first, let's talk about the variable. All of these are color-coded in this example equation for you. So the variable is the unknown value represented by a letter. So we can see in this equation that the variable on both sides is x. The coefficients are the numbers being multiplied by the variable. So we have two coefficients in this equation. On the left, the coefficient is 2, and on the right, the coefficient is -6. Constants are fixed terms, which simply means they are numbers without a variable, and they don't change. So on the left, our constant is 8, and on the right, our constant is 24. So we'll use some of those terms as we work through solving an equation with variables on both sides. I'm going to go through the 3 steps as we go along and solve this example equation so you can actually see them played out. So step 1, you want to check each side of the equal sign and see if you can distribute or if you can combine any like terms. So let's look at this equation as an example. On the left, 5x plus 17, nothing can be distributed or combined, so I would leave it as is. However, on the right, because of these parentheses, we see that we need to distribute 2 or multiply it by each term inside parentheses. So I would write the right side as 2x minus 4. So that's step 1. Now step 2, we need to collect the variable terms on one side of the equal sign, and then the constant terms on the other. And we'll do that using inverse operations. So first, you actually can collect them on either side, but if I start with my variable terms, 5x and 2x, I'm going to circle these, I choose to collect them on the side where the coefficient is bigger because it usually helps me avoid negative numbers. So to do that, the inverse would be to do the opposite of what's happening. So if I want to remove 2x, it's a positive 2x. So the inverse would be to subtract the whole term. Subtract 2x. If I do it to one side, I have to do it to the other. So in subtracting, that will cancel 2x on the right. I'll draw my line here. And then 5x's minus 2x's leaves me with 3x. And I will write down the rest of the equation. Okay, so now my constants, 17 and -4, I need to collect those on the other side, the right side of the equal sign. So let's undo the adding 17 by subtracting 17. That will cancel it from the left, and it leaves me with 3x equals -4 minus 17, which is -21. And that's step 2. You'll see we finished step 2 because we got the variable terms on the left and the constant terms on the right. And the last thing to do then is solve. Use inverse operations to isolate the variable. So instead of 3x, we want to know what x equals. Well, 3 is being multiplied by x, so undo multiplication by dividing both sides by 3. Here, that will leave us with 1x equals -7. So that's our first example. We are going to go through 5 examples total. So anytime you see a new problem, feel free to pause the video and try working through it first to see if you can solve it before seeing the solution worked through. So find the value of x needed to make the equation true. I don't see any distributing, so now we're ready for step 2, where we collect the variables on the same side. I'm going to take mine to the left since 8x is larger than 4x. So step 1, I'm going to subtract 4x from both sides. That gives me 4x minus 7 equals 21. Now I want my constants on the right, so I'm going to undo subtraction of 7 by adding 7. This cancels and leaves me with 4x equals 28. Now I want to know what just x equals, so I will undo that multiplication and divide both sides by 4 to see that x is equal to 7. Let's look at another equation. Solve the equation below. The first step, let's check. And on the left side, notice that we have like terms that need to be combined. We have negative 9n and then a positive 14n. I'm always going to circle the sign that's in front of the term to see if it needs to be added or subtracted. So if I combine negative 9n plus 14n, that gives me 5n. And now I'll write down the rest of the equation. Okay, I'm ready now to collect my variables, and I'm going to take them to the right this time since 6n is larger than 5n. So I'll subtract 5n from both sides. And that gives me positive 9 equals 1n. So I'm just going to write n. We don't have to write the 1. Minus 12. Now we're trying to isolate the variable, get n by itself. So let's undo the subtraction of 12 by adding 12 to both sides. Here this cancels. 9 plus 12 is 21. So we know that 21 equals n, or let's always write the variable first. N is equal to 21. All right. Find the value of y needed to make the equation true. Well, there's no like terms that need to be combined and no distributing. So let's look at our variables. I'm going to take them to the left since 3.5 is greater than negative 1. Technically, this says negative y, but I could write negative 1y. There's an understood 1 there if it's just the variable. So this term is negative. So if I want to cancel negative y from the right, I need to add y to both sides. Or add 1y if that helps. So 3.5y plus 1y would give me 4.5y equals 31.5. Now I need to isolate the y by undoing the multiplication and dividing by 4.5. This will leave us with y equals 7. Okay, in this equation, we see that on the left, there are parentheses, which means we need to distribute the 1/2 to both terms inside. So let's rewrite the left side as 1/2 k minus 5, because 1/2 of 10 is 5, equals 1/4 k plus 7. Now with these variables that have fraction coefficients, I'm going to rewrite 1/2 as 2 over 4 because I'm giving it a common denominator with 1/4 that helps me see that 2/4 is greater than 1/4. So I'm going to bring my k's or my variables to the left. I'm going to subtract 1/4 k from both sides. 2/4 minus 1/4 is 1/4. Now I can add 5 to both sides. That leaves us with 1/4 k equals 12. I'm going to move this up here so we have more room. 1/4 k equals 12. 1/4 is being multiplied by k. So technically to remove it or undo it, we need to divide both sides by 1/4. Over here, I'm going to write my division out to the side because I want to remind us that dividing by a fraction is the same as multiplying by its reciprocal. And reciprocal means we switch the numerator and the denominator. So if I switched 1/4 and switched the 1 and the 4, it would be 4 over 1, which is the whole number 4. So 12 times 4 shows us that k equals 48. Now we have one more example to apply equations with variables on both sides to a real-world situation. So it says that Armin is choosing between 2 gyms to join. Planet Fitness charges $0 for enrollment and $79 per month. Fit Nation charges $99 for enrollment and $62.50 per month. For what number of months would it cost Armin the same amount to be a member at either gym? Okay, So the unknown here is that we are looking for, I'm going to call it M. We're looking for the number of months where it would actually cost the same to be a member at either location. So I'm going to abbreviate. We're looking for when Planet Fitness would cost the same as Fit Nation. So how can we represent Planet Fitness? Well, it's $0 for enrollment and $79 per month. So we can represent $79 per month through multiplication, 79 times M. Fit Nation has a $99 enrollment fee, so that's usually a one-time payment, and $62.50 per month. So let's start with the $62.50 per month, but then the enrollment would add $99. So now that we've set up our equation, we can solve for M, and that will tell us when both of those gyms, their cost would be equal. So I'm going to bring my variables to the left since 79 is greater than 62.5. Okay, so that will cancel from the right. And over here, when we subtract, that leaves us with 16.5 M equals 99. So to isolate M, we need to divide by 16.5. That will leave us with M equals 99 divided by 16.5 is 6. So we would say that after 6 months, or right at 6 months, it would cost the same to be a member at either gym. Well, that's it. We have gone over the parts of an equation and how to solve equations with variables on both sides of the equal sign. So great job, and thanks for listening and learning.